Okay, so for number 4, we're going to draw the angle 11 pi over 6. So it happens to be one of the special angles, so you guys should all be familiar with where it is. So here's the 0, and 11 pi over 6 is approximately right here. That. So it's in quadrant 4. And then to add another positive coterminal angle, we're going to add 2 pi to 11 pi over 6. So we're going to get common denominator, so that's 12 pi over 6 plus 11 pi over 6. So that's going to be 23 pi over 6. We're going to subtract 2 pi to get a negative coterminal angle, so that's 11 pi over 6 minus 12 pi over 6. So that gives me negative pi over 6. Alright, so 210 is another angle on another special angle. We're going to draw it first, so here's a 0. And so 210 is approximately right here. So it goes like that. And this would be in quadrant 3. And to get another positive angle, we take 210 and add 360. So that gives us 570. Oops, we're thinking about money. 570. And to get a negative angle, we subtract 360 from it, so I'll just put it like this. So it's negative 150. So that's a positive. Now these are not the only answers, as you know. We could keep adding 360 or subtracting 360 to get other coterminal angles. So for number 12, we're converting to radians. So I used the conversion factor, pi over 180. This would be the exact value right here, but they want it rounded to 3 decimal places, so the answer that we're going to put down is 3.927 radians. Okay, so number 16 is converting a radian to a degree, so the conversion factor is 180 degrees over pi. In this case, I can just go ahead and cancel this and this, and then 5 goes into 180, 36 times, like that. And you just multiply negative 3 times 36, so that gives you negative 108. Okay, so for 20, I'm just going to use the calculator. And when you convert it to decimal degrees, it becomes negative 234.667. Okay? Again, number 24, just straight into the calculator using the keys that I showed you the other day in class. And so that would be 25 degrees, 48 minutes. So if you remember from integrated 2 or geometry, complementary angles add up to 90 degrees, and supplementary, so these add up to 90, and supplementary add up to 180. So in terms of radians, 90 is pi over 2, and 180 is pi. So to find the complement of pi over 12, we're going to take pi over 2, which is 90 degrees, subtract pi over 12, and so we need a common denominator, which is 12, so this becomes 6 twelfths. So that's 5 twelfths pi. So that's the complement right there. For supplementary, we take pi minus pi over 12, so that's 12 over 12, right? That's pi. So that's 11 pi over 12. And that's the supplement to pi over 12. Okay, so 32 is in degrees, and they want the complementary and supplementary angle to 84 degrees. So for complementary, we take 90 minus 84, so that's 6 degrees. And for supplementary, we take 180 minus 84, and that's going to be 96 degrees. So for 36, we're going to use the arc length formula. S equals r theta, so they want theta in radians, so we're dividing by r. And so the arc length for 36 is 31 inches, and the radius is 12 inches. So that's pretty much it, but you could take a calculator and get the decimal. So when you put 31 over 12 in a calculator, you get 2.583 radians. Okay, that's it for that one. Okay, so for part A, they want the revolutions per minute. So that means that we need to solve for omega, because omega is the link between, to get us to this. So I'm going to divide both sides by r to leave omega by itself. So then 28 miles per hour, divided by, I'll write it as 676 feet, like that, as an improper fraction. So I'm going to convert miles to feet. So 1 mile is 5,280 feet, and I'm going to and that'll cancel mile, and then and then cancel feet too, and then 1 hour is 60 minutes, and that'll cancel hour. So take a calculator to put in all the numbers, and then that's going to give me radians per minute. So we get 2,112 radians per minute, because remember this is omega b, v over r is omega. So now we're going to take 1 revolution is 2 pi radians, and that's canceled, and then so we divide that by 2 pi, the 2012 divided by 2 pi. So for B, we actually had the answer for B before we have the answer for A, because radians per minute we had already calculated over here earlier. So I just copied it down right here, and that's it. So what is 44, what it's asking is for the coordinates on the unit circle that correspond to 4 pi over 3. So this is quadrant 3, so it's going to be negative 1/2, negative radical 3 over 2, and that's it. So negative 5 pi over 6, again, negative means that you're going clockwise, so I have it right there like in that red orangey color. And so that angle corresponds to 7 pi over 6 on the unit circle. This angle and this angle are coterminal. So the coordinates for this would be negative radical 3 over 2, negative 1/2. So negative pi lands on the same spot as positive pi. Okay? And so you have the sign of negative pi is your y coordinate, so that's going to be 0. Cosine of negative pi is your x coordinate. Tangent is y over x, so it's 0. The reciprocal of 0 is undefined. The reciprocal of negative 1 is negative 1. And again, the reciprocal of 0 is undefined. So the angle negative pi over 4 is coterminal with positive 7 pi over 4. So they have the same values, the same ordered pair. So the sign would be negative radical 2 over 2. The cosine would be positive radical 2 over 2. And then y over x, you take this number over this number, and you get negative 1. And the other three, alright, so here I showed on the right side how you take the reciprocal of this number, and you have to rationalize it because you have that square root of 2 down there. And so this is how you rationalize it, and you keep, you work it out, and then the 2's cancel, and so you're left with negative radical 2. So likewise, secant would be the reciprocal of cosine, so it's positive radical 2, and cotangent reciprocal of tangent would be negative 1. Alright, so for 60, I converted the negative 13 pi over 3 into a mixed number, so it's negative 4 1/3. And I'm going to draw it for you so you can see where it terminates, where it ends. So here's 0, and so negative 4 pi, right? So it's going to be negative 1, 2 pi, 3 pi, 4 pi, and then a third more. So a third of a pi is approximately right here. So it's going to land on 5 pi over 3. That's where it terminates. So it has the same value as 5 pi over 3, which is 1/2. Okay, number 64 deals with the even-odd function, so just a quick reminder. Here's positive theta and negative theta, and then these are the corresponding coordinates. Notice that cosine, which is x, does not change regardless of whether you have a positive or a negative angle. It's the same sign. So cosine of negative t would be equal to cosine of t. So okay, so here's 68. Hold on. 68. I showed all the different ways of solving it, the possible ways depending on your calculator. And so there's the final answer. Okay, so 78 is similar to the previous one, to, what was it, 68? Just you have to make sure you're in degree mode. Okay, and you put it in exactly as you see it. 52 degrees, 12 minutes, and then do the sine for part A, do the sine, and then reciprocal. For B, you do the 66, 7 minutes, then you do the cosine, and then reciprocal. And those are the answers you get. So for 95, you have the angle 330, and they want you to find the reference angle. Remember, reference angle is the one that the terminal side makes with the x-axis. So 330 is right here. And so that means that this angle right here has to be 30 degrees. So this is the reference angle. For 98, I converted the 9 pi over 4 into a mixed number, 2 1/4. And so now I'm going to draw the angle. So it's going to be, here's 2 pi, and 1/4 pi would be about here. And so that would be theta. And so the reference angle would be the angle made by the terminal side, which is this one, and the x-axis. So that would be theta prime, and that would be pi over 4. For 101, negative 6 pi over 5, that's negative 1 1/5 pi, right? That's negative 6 over 5. So then that means I'm going to draw my 0, and then 1 1/5 pi would be somewhere around here, because this is pi, negative pi, and then a fifth more. So right here. So this is theta, and the reference angle is the one formed by the terminal side and the x-axis. So this would be theta prime, and this would be pi over 5. Alright, so the last 4 problems are on the screen. Basically, it's just, do you know your unit circle or not for numbers 104, 107, and 110. For pi, again, it goes around 2 times, and it lands right there. Negative 3 pi goes around once, and then it lands right there. This one, you have to take, make sure you're in radian mode, and then do the cosine of 12 pi over 5, and then the reciprocal. And then that'll give you this answer right here. Okay?